Hello, welcome to another problem session. Today we're going to talk about a problem in projectile motion. So this is a large class of problems, goes by the heading projectile motion, and favorite of lots of exams. Okay, so here we have a situation in which there's a 1 meter height, some 1 meter height, and as always you should draw the figure before you proceed doing the problem. Equations will follow once you draw the picture. Okay, so it takes a minute or two, but you get a sense of the problem, and over here is gonna come and hit. So this is the initial and this is the final. It's just before hit. So the first is how long is the ball in the air. So what's the time between initial and final, and the second one is where the ball will land. So what is the x and y coordinate of that point. So that's the B and that's the A. What's the velocity of the ball with this? Okay, so at this point it's going to land. It's going to hit the ground, so it's going to velocity be 0. That's going to be incorrect, because what we mean here is just before it hits the ground, an instant before it hits the ground, it's actually going in that direction. That's the velocity direction. Initially the velocity direction is in that direction. This is the initial velocity at the initial point. And it's given to be like that. It's given to be in that direction is 30 degrees and the speed is 22 meters per second. Okay. We said that we can ignore the air drag. That means assume free fall, which means the acceleration is pointed straight down, and it has a value g, straight down. Acceleration vector is pointed trace down, g. Okay, so you probably know that this is a vector problem in which a good strategy is to separate x and y components of velocity vector, acceleration vector, v vector, and vector for the initial position and vector for the final position, which means we need to pick a coordinate system. You could pick normally students like to pick a coordinate system with an origin here. It's like, and they'll pick a coordinate system like this and this. But I find then you have to carry this guy with you, xi and yi with you. But let's do the traditional way. This is the traditional way, and I actually like to do it this way. But if you want to do it my way, maybe you can do it after I'm done with this. Okay. But I'm going to do this origin and this position, this direction x and this direction y. So this is the initial. So at the initial time, you have xi is 0, yi is 1 meter. And then there's a velocity is pointed that way. That means I need to separate this in terms of its x component and in terms of y component. So even if you have origin over here, to break this vector into x and y, you will have to draw this vector as if the origin was at the tail of the vector. So you redo vector, initial vector this way. So this is the tail, and this is 22 and this is 30 degrees, and so this will be the v initial x, and this will be v initial y. So v initial x is going to be v0 cosine 30 degrees from this, because this is adjacent, and this side is same as opposite, so it's going to be viy will be v0 sine 30 degrees. And if you I worked this out earlier just to prepare for this save time, and I have the answer. This is 19 meter per second, and this is 11 meter per second, because sine 30 degrees is half. Okay. So these are the initial, these two things for the initial. This is x, and this is the initial y. And for the final, we know that this is y0, so this has y equal to 0 also. So y final equal to 0, and x final is, we need to figure that out. V final x, if I look at this guy and I say it's going to fall this way, so there's some angle here, but we just want to keep v final x and v final y, and this should be negative. All right, and v final y, we just keep it like this. So these are the initial, this is not known and this is not known, and then acceleration between these two, initial and final, between initial and final, between here to here, you have acceleration ax is 0 and ay is minus g. Why? Because I do the exactly same thing. You have x and y, and acceleration vector is pointed this way and has magnitude g. All right, so so that's this. Another thing, between here to there, time is t. So like t initial is 0 and t final is t. Then this time is the duration between initial to final. Okay, sometimes I may write capital T just to say this t is a generic time between here to there. Probably I'm gonna do it, say capital T, which we don't know, and so this will be capital T, t equals to capital T. Okay, I think we got all of the things right, and then the questions we need to address is in A, how long the ball is in the air. Okay, so you probably have done this kind of problems before. Let's go through the steps. So because if you look at just the x part, and you have acceleration x is 0 and time is t, so in this column you have unknown here, unknown here, unknown here. So there's not enough information to just get all of this from this column, right? Over here, ay is minus 9.8 meter over second square, and it's the same time. This is not known, this is not known. So there's only two unknowns. So in any axis, if you have just two unknowns, you can solve using this equation. So we handle, although you will see that B requires you to go to the this question, because we already know this one. Okay, so YF. So let's do the Y only first. Y first. Do Y first. So I hope you understand why I'm doing Y first rather than X, because that's important. Actually, many times students are stuck at this point. They can generate this information, but then the next step, what is to do? What to do about the next step? And you just have to count the variables like I counted here. This, there are 3 in this in the X direction, and there are 2 unknowns in the Y direction. So attack the Y first. Okay, the Y first. Well, because I got this, and this, it seems like the equation to use is Y final minus Y initial equal to V0 YT plus half AY T square. And you can see this is only unknown here. Everything is known. So Y final is -1. Actually, Y final is 0. This is -1. This is 1, so this becomes -1. The important here, all the signs are important. Make sure you understand all of this. V0y is VIY, which is 11 T plus half, and this is -9.8. Sign important here. And this is plus, so this minus becomes and T square. So this quadratic equation, now if you solve it, you're gonna get two answers. T1 is -0.1 second, and T2 is, I believe I solved earlier, 2.33 seconds. So what is this minus thing? Well, minus thing is saying that in the same situation, at the same height, so this is y equal to 0 height. Remember, this all I'm doing y. So this information doesn't even know about the x. So all y. So at the same height, had I let the ball actually shot the ball this way from here. So what will be the time t1 if this is the time t2? So this ball will go the exactly same route, and make sure when it gets there is 22 meters per second. So that's the time, and that's why it's negative. So earlier than 0, this time is 0, so this will be negative and this will be positive. All right, that's a lot of sign things that choices have to make. So our answer will be this will be our answer for this problem. So we answered A, so that's A. Where on the ground the ball, we already said we already know the y part, so we need to figure out xf. So we need to take t, and so now this t goes into there, and this is the t, not that t. I don't use it. That's the time for this problem, and so this is the time for t equals t2. So we need to figure out what this distance, and so xf minus x0, and I need to figure that out. Well, if I knew velocity, this velocity, then I can average the velocity and times t. But because acceleration is 0 in this direction, this acceleration 0 means velocity didn't change in that direction. So this will mean if I use a v final x equals v initial x plus axt, this will be 0. So this we also know this. So xf will be xf minus xi will be v average along the x direction times t. Using this, I get xf equals to, this is 0, and this is average of this 19. Average will be same because this is the same thing, so this will be 19 plus 19 over 2t, which is 19t, which is 19 times 2.33. So use the calculator already, and this is 44.3 meters. So that's the answer for B. Okay, so how are we gonna do the C? Well, we already know this, we figured out this, we need to figure out that. And that's the last thing in this column. And we can just do VF y equals to VI y plus AYT. And then we have all the information. Vy is 11 plus minus 9.8. Again, the sign became very important. And t is 2.33, and this turns out to be minus I believe 11.9 meter per second. So final velocity vector has along the x direction is 19 meter per second, and along the y direction it has minus 11.9 meter per second. Well, I can convert this into speed and the direction information. So x and y, I draw this vector, and this is going to be 19, and this is 11.9 minus 11.9. So that's the angle theta I want, and that's the speed I want. Then I could just VF will be square root of 19 square plus minus 11.9 square. You just overkill here because when it's squared, that's going to become positive. And that one turns out to be 22.4 meter per second. And this angle theta will be arctangent of this side over this side, arctangent of minus 11.9 over 19. So when you work it out, that turns to a minus 32 degrees. So choose another pen. So this is negative. What does negative mean? It means I go to the x-axis and go in a clockwise direction. So this is clockwise. So you have a clockwise, and my computer's getting me in trouble today. So the final velocity, we can say VF is equal to 22.4 meter per second and 32 degrees clockwise from x-axis. So that's another way to say it. This is all another way to say it. So those are the answers for part C. So we've done part C, part A, part B, and part A. Part A. How do you get y as a function of x? Well, so So we found that over here it went like this. At any arbitrary time t, because this is v0 and this was the v0x, and you have a v0 vix v0. So if you had some arbitrary time, you had an x-axis and y-axis. This x was this v0x, which was 19t, and the y at any time were v0y, which was 11t plus half minus 9.8 t squared. So this is, we'll call it parametric equation of the trajectory, right? So and the t was between 0 2.33 seconds. So if you plot it, you get all the coordinates of the trajectory. If you get y in terms of x, all you have to do is solve this t equals to x over 19 and plug into this and eliminate t from that equation. So y will be 11 over 19x. This is minus 4.9, and you have x squared over 19 squared. So this will be the answer for part D. Y is a function of x. Okay, it's been a long video, so I'm going to stop here, and I'll see you in another video. Bye.